Question 8. A particle of mass 6 kilograms is initially at rest, so it's 6 kilograms initially at rest. It's acted on by a force R, which is AI plus 10J newtons on a bearing of 300 degrees. So, this is slightly ambiguous, so it's important to clarify at the start what they're meaning here. So, north is going to be in that direction. The unit vector I will be in that direction, and J will be in the northerly direction. That's a sort of convention, although they've not explicitly said that here in this question. Okay, so we've now got to find the value of A, the exact value. So that the fact they've used the word exact suggests no calculator should really be used in the question, or for that part of it at least. And we're told that the force is acting on a bearing of 300 degrees. So we've got 300 degrees, there's north, so that's 300 degrees. So this in here is 60 degrees. And we need to make a right-angled triangle. So we've got J is 10 newtons, and we've got A here. So we know tan of 60 is equal to the opposite A over 10. So now tan 60 we should know is going to be tan of 60 is root 3. So A equals 10 root 3. I'll look at that and I'm fairly happy, but there's one slight error in there. Yeah, and if you look closely, this is in the negative direction. So really what I've worked out here is the magnitude of A, the length of that line, just using the triangle. So A itself is in the negative direction, so it'll be minus 10 root 3. B, the magnitude of R. Well, that's a standard Pythagoras question. It's the I component, because we've got a right-angled triangle, squared, plus the J component, squared, square rooted. So here we're going to get negative times a negative is positive. 10 squared is 100 times 3, so we get 300, plus 10 squared is 100, square rooted, so it's a square root of 400, so we get 20 newtons for the magnitude of R. Part C, work out the magnitude of the acceleration of the particle. So we've got the mass, I hope in the question, otherwise we're going to have a problem. Yes, we do. Look, there we go. The mass of the particle. The mass of the particle, is 6 kilograms. So we've got mass and a force, and we want acceleration. So hopefully you remember F is equal to ma. The resultant force is 20. The mass is 6, so we can find A. So A is equal to 20 over 6, which is 10 over 3 meters per second squared. Part D. Find the time it takes the particle to travel a distance of 640 meters. So again, key knowledge to remember. Force is constant. Therefore, acceleration is constant. So let's assume that question. Okay, so what are we asked for? Find the time it takes to travel a distance. So the question says find t. To do the distance 640 meters, we know A equals 10 over 3. Let's go back and read the question, because we're going to need something else, a U or a V. a particle of mass is initially at rest. At rest. So U equals 0. Okay, now hopefully you look at T, S, A and U and you think of using S equals UT plus a half AT squared. So 640 is equal to 0 times T plus a half A, which is 10. over 3 lots of T squared. So if we tidy that up, we've got 640 is equal to 5 over 3T squared. So T squared equals 3 lots of 640 over 5. Well, dividing by 5 is like dividing by 10 and multiplying by 2. So we get 6 lots of 64, which is 360 plus 24, so that's 384. So T is equal to the square root of 384, which is going to be a little bit less than 20. So we check that in a calculator, 19.6 seconds.